Hello everyone, welcome to the lesson Linear Programming Kcse 1995 Paper 2 question number 24. A manufacturer of jam has 720 kg of strawberry syrup and 800 kg of mango syrup for making two types of jam, grade A and grade B. Each type is made by mixing strawberry and mango syrups as follows. Grade A, 60% strawberry and 40% mango. Grade B, 30% strawberry and 70% mango. The jam is sold in 400 gram jars. The selling price are as follows. Grade A, 48 shillings per jar. Grade B, 30 shillings per jar. A. Form inequalities to represent the given information. B. Part 1. On the grid provided, draw the inequalities. 2. From your graph, determine the number of jars of each grade the manufacturer should produce to maximize his profit. So that is a question. Let's go to the first part of the question where you're supposed to form the inequalities to represent the given information. It is important to highlight the important information that we're given here. One is this manufacturer has 720 kg of strawberry syrup and 800 kg of mango syrup. And below here, that is what it has to use to make these two types of jam, grade A and B. For mixing purposes, for grade A, he has to ensure that each jar has 60% of strawberry and 40% of mango. Then grade B, 30% strawberry and 70% mango. Now the first thing will be, since we're dealing with the number of jars here, we need to let the number of jars for grade A, so let the number of jars, the first thing, so let the number of jars for grade A be represented by X. And also we can let the number of jars for grade B be represented by letter Y. So the other thing that we need to highlight here, with this information that we're given here, that the jam is sold in 400 gram jars. So the jam is sold in 400 gram jars. So that means that one jam should contain 400 grams. Now using this one, we're supposed to then look at this kg of strawberry, 720 kg. How many jars will that one produce? For 800 kg, that is for mango, how many jars will that produce? So if one jar must contain 400 grams, what about 720 kg? And when we convert 720 kg, just write it here, 720 kg is equivalent to 720,000 grams. You just multiply by 1,000 to convert kg to grams. So what about 720,000 grams? How many jars will this one produce? So you just need to divide. So 720,000 divided by 400. When you work out this using a calculator, 720,000 divided by 400, you get 1800 jars. So strawberry, 720 kg of strawberry will produce 1800 grams. Now in mixing, we are going to first consider the strawberry for both grade A and B, and then we go to the mango. So the number of jars produced by mixing 60% of strawberry, so each jar, so it will be represented by 60%, which is 60 divided by 100, multiplied by the number of jars for grade A, which is X. That will give the number of jars produced by mixing strawberry, that is 60% of strawberry. Then plus the other percentage here is 30% strawberry, that is for grade B, for grade B. So for grade B, so that one will be 30 divided by 100, and then multiply by the number of jars for grade B, that will be 30y. So this expression represents the number of jars that will be produced by mixing 60% of strawberry for grade A and 30% of strawberry for grade B. And this one should not exceed 720 kg, of which we have already calculated and found that 720 kg will produce 1800 jars. So this one should not exceed. So it should not exceed means what? It would be less than or equal to 1800 jars. We've just converted here. So we can simplify these. This one is the same as 6 divided by 10x plus 3 divided by 10y less than or equal to 1800. If we multiply everything by 10, we'll get 6x plus 3y should be less than or equal to 18,000. We multiply each term by 10, get rid of that denominator. Then you can see everything here. You can divide everything and simplify these by 3. Dividing everything by 3, we get 2x then plus y less than or to 1800. 18,000 divided by 3, we get 6,000. So this one gives the first inequality. That is the first inequality that you obtain. Now let's go to the second inequality. The second inequality, we get it here where we have 40% mango and 70% this one 70% mango. Yeah, now for mango we have 800 kg. That is a syrup that is available to produce these two grades. So 800 kg. The first thing is to note how many jars will be produced by 800 kg. So you just go back to where we said that one jar should have 400 grams. So what about 800 kg? And 800 kg is the same as 800,000 grams. And so when you divide these 800,000 grams divided by 400, this one will give 2,000. So 2,000 jars. So that means that 800 kg syrup for mango, this one can produce 2,000 jars, since one jar should have 400 grams. So then for grade A, 40% of the mango, so 40% for these are we going to rate it. So 40% is 440 over 100. Then multiply by the number of jars for grade A. Then the other percentage is this one is a 70% mango. So that one would be 70%, which is 70 over 100. 70 over 100 multiply by the number of jars for grade for grade B, which is y. And this expression now shows the number of jars produced by mixing 40% of the mango for grade A plus 70% of the mango in grade B. This is the number of jars that are going to be produced. That should be less than or equal to 2,000 jars. They should not be more. So this is the same as a 4 divided by 10x plus 7 divided by 10 y should be less than or equal to 2,000. Multiplying everything by 10 to get rid of this denominator, you get 4x plus 7y is less than or equal to 20,000. We've just multiplied each term by 10 to get rid of the denominator, and this gives the second inequality. So now we have two inequalities. The first one is here and the second one is here. Those are the two inequalities. Now the next thing is to now find, do we have another inequality that you can get now? When you look at the other information, the selling prices are as follows. Grade A 48 per jar and grade B. So from here we can also get another important thing. So for grade A, remember the number of jars for grade A, so the total amount, this one is the is going to give us the objective function, which we're going to use to maximize the profit in part B of the question. So grade A, 48 shilling per jar. How many jars are there for grade A? There are X. So this one will be 48X. That will represent the total amount of money obtained by selling all the jars for grade A. So if one jar 48 shillings, what about X number of jars? Then for grade B, one jar should go for 30 shillings. So we have how many jars for grade B? We have Y jars, so that will give 30 Y. So this one is going to give us a objective function that we're going to use to maximize the profit. So this one is very important. 48X plus 30Y, 48X plus 30Y. That is called the objective function. That is called the objective function, and is the one that is going to assist us to either maximize or minimize the profit. So that is very important. When I go to the other information that we have there, I think we are through with the information. One thing that is remaining now, the number of jars for grade A should be X, the number of jars for grade B should be Y. So meaning that X and Y should not be any figure that is negative, it should be non-negative. So it should be either less than, greater than, or equal to 0. Those values, the number of jars is not supposed to give us negative, they should be non-negative values. So meaning that since we let the number of jars for grade A to be X, so X, the number of jars, should be greater or equal to 0, and also Y should be greater or equal to 0. Now we have all the inequalities now. All the inequalities are there. So we have this one, we have this one, we also have this one. Objective function is there. We also have that one. The other one that we have is here. So now we can proceed to the next question now. Part B. On the grid provided, draw the inequalities. On the grid provided, draw the inequalities. So what are we going to use to draw the inequalities? The most important equations here, the inequalities that we're going to use is the first one, 2x plus y. 2x plus y. This is part 2x plus y is less than or equal to 6,000. That is the first one. Now, to draw the inequality using this inequality, to draw the graph using this inequality, we're going to treat this one as an equation of a straight line, and an equation of a straight line should be drawn by using 2 points, any 2 points that you can use here. It can give us, so we just take this sign as equals 2x plus y, just treat that one as equal for the purposes of just drawing the line. We can just replace that sign less than or equal to with equal sign, just for the purposes of drawing the line. Now we need to have at least 2 points to draw this line. 2 points would be enough. So when the first one, let me check, when x is 0, if we can let x to be 0, y will be 6,000. And then if we let y to be 0, if we let y to be 0, x will be 3,000. So we're going to use this one, these two, to draw that line. 2 points are enough, but you can use that one for confirmation. Then from there we can go to the other equation, and the other equation is 4x plus 7y, 4x plus 7y less than or equal to 20,000. That is 20,000. Again, here we can just have any 2 points. Any 2 points will give us the straight line. So let me choose when x is when y is 0. I think when y is 0, just replacing this inequality. When y is 0, this will be 5,000. X will be 5,000. Then what about when you check when y is 2,000? when y is 2000, you can use any value provided to just not disturb you when you're plotting. This will be 8000, 12,000. This will be 1500. Then will be 1500 when y is 2000. So these two will help us to plot that. Then for the others, x is greater or equal to 0, that will be the y-axis, and then the other one, y is less than or equal to 0. So just draw this line, x is equals to 0. This one will be the y-axis, and then this one will be the y-axis, and then y is equals to 0. This one will be the x-axis. So those are the lines that we need to draw now. So we're going to draw the first line here using these 2 points, and then the second one and third one. So let us go to the graph. Can go to the graph. I have already chosen the scale based on the values that I have here. So when you look at the values that I have here, 6000, this one is 3000. Sorry, this is supposed to be 3000 when x is 0. When y is 0, x is 3000. So based on those values, I have chosen a scale 1 centimeter to represent 1000. So y-axis represents the number of jars for y. This one is for grade, something here, the number of jars for grade we go for that as the number of jars of y, and the number, I think it's okay, the number of jars for grade y and x for both the y-axis. So there's no problem with that. So now we can plot the first one. The first one is 0. We're starting with this one, 2x plus y is equals to or less than or equal to 6000. So when x is 0, y is 6000. When x is 0, 6000. So 0 or 6000 will be here. 6000 will be here. And then the other point very fast, this one is x 3000 0 3000 0 3000 0 will be here. So 3000 0 and 0 6000. So that line, okay, so I'm to draw that line. That line should be pass there. Let me draw it properly. That line should be like that. Then the other line that you need to draw, that will be a continuous line, since you can see it is less than or equal to. The other one is 4x plus 7y less than or equal to 20,000. So 5,000 0. So 5,000 0. 5,000 0 will be here. And then we have 1500 2000. 1500 2000. 1500 is between here, between 1000 and 200. 15,200 2000. 1500 is in between here, then 2000 will be somewhere there. So these are the points. We have a point here, another one here. So drawing that line should pass through that point like that when you draw it. Like that. Now we have the two lines. You can see them. So the first one is 2x plus y. You can write them here. So this one is 2x plus y less than or equal to 6,000. Then we have the other one, which is 4x plus 7y less than or equal to 20,000. So those are the two lines, and both lines are supposed to be continuous. You can see both of them are less than or equal to. So any point on those lines is also important, and it is not supposed to be ignored. Any point that lies on those lines. So from there, we need now to shade the unwanted side. To shade the unwanted side, you just need to do it like this. Like for the first one, 2x plus y is less than or equal to 6,000. If you pick a point on this side of this line, like a point like 0, 0, you notice that you get a 0 is less than or equal to 6,000. So that one satisfies. So automatically this one becomes the unwanted side, since the point that we have picked on the other side of that line has satisfied the equation. We do the same for the other equation. Which is 4x plus 7y is less than or equal to 20,000. If you pick that point again 0, 0, you notice that 0 is less than or equal to 20,000. So that one also satisfies. So you again shade on top of that line. So the region that remains, which is R, this one is called the feasible region, or the required region, and that is where we are supposed to get our solution. Now the other lines, this is the y-axis. Y-axis is the line, the other line that was x is greater than or equal to 0. That is the line. Then for the x-axis, this was the line x y is greater than or equal to 0. That is the x-axis. So now we plotted all the lines, and you have the region. The required region is there. These are shaded here. The next thing that we're going to do now is to go to the last question, and the last question is from your graph, determine the number of jars of each grade the manufacturer should produce to maximize the profit. This is called the process of maximization. Now, to maximize the profit, we use the objective function. This objective function that we have here, 48x plus 30y. We got it from the cost of grade A, the selling prices, 48 per jar for grade A, so that you got 48x, and 30 per jar for grade B, that is 30y. Now, to maximize the profit, this is what you do. You can use several methods. You can use the sliding line, or you can use the inspection method. So I will use the inspection method. And to use the inspection method, you simply need to look the point of intersections that borders the required region. I repeat this. To use the inspection method, you simply need to look at the required region and look at the point of intersection of those lines bordering that region. We have several. One is the origin, 0, 0. We also have 0, 3,000. You can see these. So one is 0, 0. That is what you're going to inspect. And then we have the other one is 0, 3,000. Those are the corner points of the feasible region. Then we also have this one again, that is here. This one, this point that is here, the intersection of these two lines. We have 2,000, not the scale, or one small square will be 200. So this one will be 2,200. 2,200. And then going up, we have 12, 14, 16 of 1,600. This is where the two lines 4x plus 7y is equals less than or equal to 20,000, and the other line where those two lines are meeting. This is the point is a point, and that point is 2200 and 1600. Then the other point is 3000, 3000. So to inspect the point that is going to help us to maximize or minimize the profit, we look at the feasible region or the required region, and then we take the corner points of that region. And the corner points, we have identified them. The corner points are 00, 0300, then 2200, 1600, and 3000. Now what you need to do now is to have the objective function and test all these points. You're going to test all these points. The objective function is 48x plus 30y, 48x plus 30y, 48x. So 48x plus 30y, so 48x plus 30y, that is. And so we are going to test using the first point. I think I should create a table here. You can just test. The first one is 00. You can test 00, 00. So when you test 00, you get this one will be 48. 0 plus 30, 0. So this one will give 0. That one will not give us any maximum profit. The other one will be 0300, 0300. So this one will be 48, 0 plus 30, 300. Now working out this one using calculator very fast. I'll test this one very fast using a calculator. So this one is now this one will just give a 9,000. Very easy. Then the other point that you need to inspect is 2200, 1600, 2200, 1600, 2200, 1600. So 2200 plus 30, 1600. So we have 48 and plus 30. That is going to give 153, 600. And then the other one is 3000, 0. The other point that you should inspect, 3000 and 0. So 48, 3000 plus 30, 0. So this one will give 48 multiplied by 3000. This will give 144,000. And you are through. Now after inspecting all those, the corner points of the feasible region, now what we need to do now is to check which one has given us the maximum profit. Automatically you can see that 2200 and 1600 has given us the maximum profit, and therefore we can answer now the question and say the number of jars that is going to give for grade A. We have 2200. This is the answer here. So 2200 jars of A. So 2200 jars for grade A, and then we have 1600, not 16,000, 1600 jars for grade B. So we have answered the question, because the question required us to go to the question up there very fast. from you determine the number of jars for each grade the manufacturer should produce to maximize the profit. So you've got it. So for grade A, we have obtained 2200 jars. Then for grade B, 1600 jars, and we have done that after inspecting and substituting the objective function, and we have noted that is going to give us the maximum profit. That is how we're supposed to solve that question. Thank you.